Excellent. So thank you very much for hosting this seminar. And I would like to apologize because I had an issue just at the moment I started to run the Zoom. My PC went through an upgrade, so I'm really sorry for that. And thank you, Gautin and Christina, to jump and start before. Okay, so let me present myself. My name is Sadeq Zougan. I have a PhD in biotechnology and a master in software programming. I have, let's say, 20 years of experience in the development, in data management, and during the last 10 years, I worked on mainly on European projects in these topics, data management. Okay, so the agenda I propose to you is the following. I will start briefly presenting Akkodis, then a reminder about the ambition and how these are related to the data management objectives. Then I will propose to you to see what approach we had to address these data management issues, and then I will present some achievements. I will go very fast on the integrations with the environmental aspects, since Gautia and Christina addressed it very well. But if you have, and then I will finish with a short demo of the tools, and if we have time, we will see the challenges and the questions. Okay, so Akkodis is a big IT companies. We provide consulting, development of solutions, acquisitions of talents, and also upskillings and of our engineer, and also of the engineers of our consultants. We are present in a lot of industry, as you can see, automotive, aerospace. In Toulouse, we are working a lot on aerospace since Airbus is here, but also we are working on energy, clean technology, and so on. Let's say we are addressing all the industries that needs digitalizations, and on about the tech practice, we are doing digitalization, software development, data analytics, and so on. So we are present in 30 countries. We are present in Spain, I see. And we have more than 50,000 engineers. So if you are looking for an opportunity, if you would like to work for Akkodis, so it is a good place. Okay, so this is just a short slide just to show where we are and what we are doing, what Akkodis is doing in DigiEcoQuarry. At the work package level, we are involved, let's say, strongly in work package 4, which is about the development of this integrated platform. Even if we are involved on a lot of other tasks, since we are implicated in the integration aspect. And at the development level, we are delivering these IQS platforms, and we'll come back soon. So this is just a zoom on where we are working. I decided to present this because it gives a good transition about the data management aspects. So the DigiEcoQuarry aims to exploit or to take the full potential of digital queries through significant breakthrough in process digitalizations and automation capability for the aggregate sector. And what is very interesting to see, and that I wanted to show you about data management, is this slide, where we can see that less than 1% of the data are used in the executions and for decision making. And where we see, what we can see here is all the point of failure that explain why we have this issue. First, the data are not used because they are not captured. Just that there is no capture of the data. So for that, the solutions is to capture the data. Second point is that data are not streamed or stored. So we need the infrastructures to store the data. Third point is the data is not accessible. Even if it is stored, it is not accessible. Then we have to manage to address it through data management aspect. After that, the data is not analyzed. So we need analytics and automations to automate this analysis. And of course, the data should be good quality to have these topics, but this is another issue. Data not communicated. To communicate the data, like what said Doughty, we need to have visualizations. We need to show two things to take decisions. And the last point is data not used in the decision making. So here you see that there is a lot of process that to be set in place in order to start using this data. Now I will come back to the concept of the project. I think that these figures you already see it, and this figure what you can see, we have a lot of processes that describe the query, and what we are trying to do is to put in place various sensors that will capture the data. And then this data will be captured at different levels, at let's say at the transport levels or at the treatment levels of the query, and this data will then be captured by different platforms, and these platforms will share the data at what we called in this project the IQS. The IQS is the platform that will collect the data from all these systems and will enable the creations of various applications or tools to enable the query users to take their decisions. And also this data can be used by different other systems like IA or the PIM applications. So now we have a clear idea on how the data will flow in the context of the project. Now, if we deep dive a bit into the objectives. We were in the concept, now we are in the objectives. So the objectives of the DigiEcoQuarry is to develop this IQS, which is an integrated platform that enables query the digitalizations through ICT solutions, BIM, and IA technologies. And here in our context, the ICT solutions are the IoT platforms, the data lake, BIM, IA models, and the data warehouse, and also the applications. All that is, we need to ensure the full interoperability of the data sources in near real time across the processes of the query and also through different queries to build smart, exploit smart and agile services. Sorry. Now that we have seen the objectives, we have additional challenges to align with in order to build these data management platforms. And I listed here a few of them. The solutions should be affordable for the query because the queries are not really rich. These solutions should connect all the activities, machines, processes, would need to be manageable by the workers because they are not really IT peoples. Adaptable, scalable, solution need to be able to work independently from any expert and able to integrate expert systems, new expert systems. So here are the challenges that we get from the queries. And here I will go very fast on it. This is the must-have characteristics of modern data management platforms. Some overlap with those that I just mentioned, but they are really interesting. It's simple, easy with less effort, less scripting, minimum software implementation, administrative work. Because otherwise, the data is not really usable. Unified. This means that we need to have to share the view on the data from the sources for all these guys working with the data. Accessibles, high performance, economic. We need to provide cloud data architectures that enables the query to control the cost. We don't need to have heavy solutions, but on heavy if we need to do a lot of computing. Governed, that means that we need to have the right access, and open. And open because we don't want to be locked, for example, to one specific system. Okay, so, and what this is what guide us Akkodis in the development of the different solutions we are trying to provide. So now, what was the approach we had in DigiEcoQuarry to tackle this issue? I did. So first, we performed the necessity requirement analysis on the network levels for the IoT platforms, the data lake, for the IA, and for the BIM. We made an inventory of all the systems that are involved in the query, and this is very important because it enables us to identify who will share the data. We performed a benchmark of the best digitalization tools, because every time when we develop platforms, we need to understand exactly what are the right tools to be used. And since we decided to go on the data lake technologies, so we identified AWS and Google and Azure as a solution provider. Then we identified and defined the global integration strategy in order to see how the data can be exchanged between all these systems. After this first phases of, let's say, paperwork, then we moved to design the solutions according to requirements, and we started doing the implementations. This is the central data management platform. Is the concept that we developed, which is included in the global IQS platforms. Then we implemented all the interfaces that enables the data ingestion and the processing of the tools. Here we developed various microservices for those that are not very let's say, aware of this technology. Is a kind of component that is involved in developing one specific activity. For example, it could manage transport data, or it could manage SCADA data or plant production data. They are really separated because they have different constraints. Then we managed the issue related to security, how the systems, the users, and will connect to the platforms, and then we put in place a data integration environment using an ETL. For the IoT part, we did the same process. We designed the applications, integrating various components. IoT components. We identified the various different use cases within the project, and also we defined the global architectures for the business management tools. I will say a few words at the end. we defined the global integration strategy between the data lake, the central data management platforms, the integration platform, and the Power BI. Because at the end, all the data is provided somewhere and will be used in another space. So the word integration is very, very important. And we created some prototype for the visualizations. So I will go, since the time go very fast, I will just show you a few elements, let's say, about the benchmark. So the benchmark that we did at the beginning, we identified generic components that need to be integrated in the data management platforms. For example, we identified that we need data storage, and we tried to find the components that are able to provide these features in Azure and in AWS. And since we need to have, let's say, an affordable solutions, we tried also to see what the open source environments provide as the tools that we can integrate in these solutions. We did the same operations for the IoT and business and business and intelligence and tools. And at the end, we arrived here in the architectures for the data lake and for the IoT platforms. In blue, you see that all these are the components that are, let's say, coming from Azure, since we selected Azure as a data provider, because Azure and AWS are very, very, let's say, similar. And what makes a solution strong is our capability to implement the solutions. And at Akkodis, we are, let's say, in the team more expert on Azure than in AWS, and we don't want it to go this way. So, but all the solutions can be exchangeable without, let's say, big issues. So let me go just a few details here in these architectures. What we can see here is that we are using Azure data storage. We are using various databases. We are using Talent for the data integrations. And at the central data management platform, CDMP, we created all these microservices. And here we can see the EDM, the environmental data management microservices. That this services is tackling all the data exchange with Plantsmith, the product that Gautier just mentioned. And here we have other components, one related to the plant productions, one related to the data lake browser, and I will say a few words at the end on this. And all this data that are flowing through these systems can be used through these APIs, which are open APIs that can be used directly by any external systems in order to streamline the data exchange between the systems. I will not go into the details on the IoT platform, except that we are using the IoT Hub and Azure Event Hub as main component. And in this slide, very quickly, we see how the platforms that we are developing integrate simply with Power BI platforms. Power BI platforms appears to be a simple tools since Query they don't have a lot of experience in the development. So if they need to modify their dashboards, Power BI appears to be, let's say, the simplest way. This slide shows the interfaces of the central data management platform with its database. in the database, it is very important because we had to store all the metadata related to the data exchange, and we have a direct interface with Azure Data Lake, where all the data are stored. Azure Data Lake, the Data Lake engineer appears very interesting because we don't have any constraints on the volumes of the data that can be stored, and we pay, that we say, as we go. If you need to store a lot of terabytes, you pay for terabytes, and if you have just few gigabytes, it appears very easy and safe. Again, we have various interfaces for visualizations of the data, and also REST APIs, which is a standard for the data exchange with the external systems. And this is the APIs that we are using with all of the external systems. This is we implemented one process. We defined and implemented one process that shows how the data can be shared, and this process is very important because it defined not only it implements not only the difficult parts of the sharing the data with the data lake, the connectivity, and so on, but also obliged the partners to give had to add various metadata related to the data they are sharing. For example, they need to precise the process, the sub-process, and they have other fields to define the metadata. And also for the files they are sharing, they need to precise which formats and the type of the files. And with this kind of metadata descriptions, any external systems can design an automated process. Here we have the central data management platform as we developed, with the first interfaces showing the data, and on the right we see the REST APIs that can be used to extract the data automatically. And now I will go a bit in the details of some microservices we developed and how and what procedures we defined. First of all, we identified all the KPIs that need to be computed. From there, we tried to see what expert systems is or can provide this data. Then we define the minimal data that need to be used. For example, if you need to compute a ton per hours, you need the tons and you need the hours. So this is really a straightforward way of working. And once we define the minimal data, then we define the data models and the data format, because we need to understand how the data will be structured. And in general, we use the JSON format as a format. With all of these information, we are ready to implement the microservices and its interfaces. And after that, it is a matter of data integrations and development of the dashboards. So let's see one or two microservices we developed in the context of the project. We developed one microservice that collect SCADA data, and I think that you already have the one presentations from Maestro. And by using this microservice, we are now able to extract the data, all the parameters that are generated by the queries. And so, let's say the digitalization now, it's ready, implemented. have all the parameters are not there, but the way of the way to implement this automation is done. For the transport data, I think that you had already presentations about, and their system is already integrated within the IQS, and we are able now to get all the data related to the transport data. Let me move on to the plant productions. Plant productions, the data are related, come mostly from the SCADA systems. And now today we have all the tools to visualize what is happening within the query. We know exactly how many tons produced for each product, and also we have all the APIs that enables the extractions of this data. And all this data will be used to compute additional KPIs, since the project need to monitor and to improve the efficiency and profitability. These are really mandatory elements toward the digitalizations. I will skip this. The next, this is another microservice that track the consumptions, and the other ones tracks the sales. So nothing very difficult, but I think that you see the concept. Now the business management tools is a concept that we addressed within the DigiEcoQuarries. Let's say there's a concept that enables to create dashboards or representations that enables query users to monitor what is happening, let's say, within the query, and if there is what are the performance of the query, what is the productions. And here we can see the strategy of integration that we applied. So the data comes here. You see from the CDMP, IoT data, or files, or the SCADA. We created various databases to store this data. Then various extraction of data sets are generated, and these data sets are then used to build dashboards. And the concept that we created in the DigiEcoQuarry is that all these dashboards can then be integrated in one big applications dashboards that enables the expert of the query to have a horizontal view on the main KPIs of the query. On the right side, you see how things are working using Power BI, which appears to be powerful for this kind of working. So we create reports. You can create reports on your computers using Power BI desktop, and then all these reports can be uploaded to the cloud and in the Power BI portal. And from this portal, we are able to, let's say, to do the aggregations and to generate one applications that can be used to see all these dashboards. So let me go very fast. We will see it. I plan to have a demo. This we see it, and now just a few words about one interesting integrations with it with Sigma for the development of dust and water sensors to collect data for forecast AI services. What we did with Sigma is that Sigma implemented different sensors trying to track dust and water in simple query. So all these sensors are sending data through one network, one radio network, and this data comes directly to the platforms that we developed within Azure. Data comes through the IoT hub, and then it is stored on the data lake. And from the data lake, the central data management platform can enable the access to this data also. And here we can see how the data appears in the central data management platforms. And also all these data are actionables. I mean that we have APIs to extract it and use it in another process. And this is what materialized here with this link. Okay, so now maybe it is a demo time just to show how things are working in real. So let's see first central data management platforms for Holcim. Go out from here. Okay, so the central data management platforms appears like this with all the data that is stored that arrives at regular basis. Here we see the automation data, that means the daily productions, and the files can be extracted manually, or the data can be extracted also through all these REST APIs. What I wanted also to show, yes, this is the plant production data, not the same as for the other files that arrived to the systems. Now maybe I can show this. Let me go back to the presentation. Sorry. The simple platform. So for simple, we don't have SCADA data, but what is interesting is that we have some data related to the data lake browser, and here you see that the data that are generated by the sensors put in place by Sigma and Simple arrived. I don't know exactly the frequency, but I think it is something like every 10 minutes or every hours we can get the IoT data. And maybe now, since the time is going very fast, I will just show how the dashboards appears in the context of Simple. We already see this, so we can have access on monthly basis on the consumable data. We can see really easily how the information related to environmental data. For the production data, we can see also some these dashboards showing the production. We use some dummy data for the consumptions, plant consumptions, and the last dashboard that I can show here is related to the transport, where we can see exactly what is happening using all the data shared by Vault. We can track the consumptions. We can see exactly what is happening within the query at the let's say at the very a regular basis, whether for transport data we can manage to have our information on daily basis. So I think that I will go back to the presentation. Sorry. Some challenges that we had. Of course, there is challenges that I can share with you. First one is the integrations with the existing ICT asset. We had an issue with to connect with the existing expert systems because there are some issue of security, and also because they are not having open APIs. And for that, for the moment, we built various proxy strategies to reduce manual inputs. For the business management tools, as I show, it appears very simple concept, but the implementation, believe me, was very, very complex. Since we had to go through the whole digitalization process, from the descriptions to the identifications of the KPIs and the definitions of the data, the models. It was, let's say, it was a really nightmare, but we managed to have something very, very interesting. Last two point. What we now have to do is what we had is to reduce the complexity of the tools, because to make them very useful by partners. And also the issue that we had is that we are lacking some data to perform some tasks within the project, and so we rely on some dummy data or simulated data. So this is all from my side.